Okay, so economics question. So I want to maximize revenue. So I'm going to be doing a derivative and of a revenue function. So I need to find revenue at some point. But let's first of all talk about the demand for these posters. Okay, so every time I lower the price by $1, I get 20 more in sales. Okay, so that means that this describes what's called a linear relationship. Okay, for every, this is like a delta y, always corresponds to a certain delta x. So it's a slope of a line. Okay, so we're going to look for, let's say y equal to, let's not do that. Let's go small p. P is price. X equals units sold. And so from the question, we know it's going to be a line. So AX plus B. And we know that when you have 480 plugged in for X, you get 28 is your price. And when you lower the price by 1, you sell 20 more posters. So what do I get from these two data points? I get 28 is equal to 480A plus B, and 27 is 500A plus B. Okay, the easiest thing to do is just to subtract these two equations, so do a subtraction. So 28 minus 7 is 1. 480 minus 500 is minus 20A. So I get A is minus 1 over 20. And if I plug that in, say, to my first equation, I get 28 is equal to 480 minus 1 over 20 plus B. So just working this out, minus 24 plus B. So 52 is equal to B. Okay, so I have my demand function. P of X is equal to minus 1 over 20 times X plus 52. So I'm still setting up my question here. I want to maximize revenue. So what is revenue? Revenue is, in this simple case, revenue is number of units sold times price per unit. Okay, so this is X times P. So X is the number of units sold, P is the price. So in our case, we get R is, we use our P function here, we get minus 1 over 20 X squared now, plus 52 X. Okay, so I want to maximize this revenue. So how do you maximize? Well, you take a derivative, set it equals 0. Take a derivative, set it equals 0 to find the critical numbers. 52 is X over 10, so X is 520. So this appears to be our answer, but it's good to check that, right? So I have 0, then I have my 520. Now my revenue function, by looking at its derivative, r prime, if I go bigger than 520, I have minus. If I go smaller, if I plug in like a 1 right here, I'll get positive. So it's increasing and it's decreasing. So this is indeed a max as expected. So x equals 520 maximizes r. So did that answer your question? Let's see what the question was. What was the question? Probably you want to find the price, right? Nope. No, I'm good. Nope. They just want to find how many posters. Okay, so I want to sell 520 posters. If I were asked the price, what is the price point that gives that maximum? Well, you just take P of 520 and work it out. But, and I would use the P function that I found up here. Okay, but in this particular question, I am not being asked that, so I am done. Oh, where'd it go? I scrolled too far. I am done with this statement here.